Hello, we were looking at the CRISP DM model. We have already seen what is business understanding, what is data understanding, what is data preparation, modeling. We have seen what are the agile steps involved in them. Let us look at the last two steps, starting with evaluation. Once the data scientist has actually finished working on the model and proven that it is statistically relevant, they pass it on to evaluation. The first thing we do in evaluation is test it against test data. It is common practice to hold out some part of the data as test data set, and the modeling step does not see this data set. And on that data set, we would like to find what is metric like accuracy, for instance. That is the step one of evaluation. After this, we try to see if the business objectives that we had set out at the very beginning are actually met with the model that we have received so far. One and two steps, these two steps may not be the same. The business objectives may be a bit more abstract, and we would like to ensure that they are also being met. The third question is, does it meet performance requirements? By performance, what we mean here is the model must be deployed in some context, and does it meet the requirements of those contexts? We will discuss more about it when we talk about deployments. The fourth question is the model unbiased and robust? Now, this is a very significant point. Let us talk about being unbiased first. It is entirely possible, and it's seen to happen in many cases, that model can have unintentional biases which you see in the data set. For instance, consider you are a bank and you are using data science to decide whether to give a loan or not to a particular person. Now, it might be that it could have unintentional biases for the gender of the person or the educational qualification of the person, and so on and so forth. It is important to go and test for whether these biases exist and also find ways to remove them. The next question related to this is robustness. Typically, the data model has been tested on a particular data set. What happens when you have small changes in the data set? For instance, a new drug has been tested for the age group of 40 to 60. What happens if I give the drug to a 38-year-old? This is the issue of robustness. Does the model robustly hold for slight variations in the data set? Again, this needs to be carefully tested out and ensure that there is robustness. The final step is to identify ways to improve the model. At the evaluation stage, you are taking stock of what you have done so far. And it is important to ask the question, can I do things slightly differently to get better accuracy, meet the objectives better, and so on and so forth. That is the evaluation step. Let's move on to the deployment phase. This is the phase where we have decided the model actually meets all our requirements and are ready to put it in use in real life. The first question is, where is the model to be deployed? Is it going to be running on my organization's servers? Is it going to run on the cloud, or on the phone of users, or on an embedded device, let's say like a drone? All these questions need to be understood here to give context to remaining steps of deployment. The next question is, what is the hardware-software stack for deployment? Depending on where the model is to be deployed, you might have very different constraints. Something like a drone might only support C++ language and needs to be written in a way it is very efficient. Whereas something on, let us say, AWS on the cloud can be written in any language that we want. So finding out what the stack is very important for deployment. The next thing is, does it meet performance requirements? Let us say on a drone, you might want to write models which can use the battery in a limited way because drone has limited energy availability. On the other hand, something on the cloud can run lot more complex code and hence be very efficient. On the other hand, if you're, let us say, a trading company and you're trading on the stock market, you need to ensure that the latency of your model is very less, because if there's a large latency, the market can actually change and you may miss the opportunity. So you need to check if the latency of your model is very small. So all these considerations go into performance. The fourth important point is, does it violate some privacy requirements? Depending on where you install a model, you might have to ensure that privacy of the user using it is actually not violated. If it is on the cloud and the data is owned by you, that is fine. But if it is on the mobile phone, let us say if you are making a keyboard app which can help people type more efficiently, then whether the data can be used for other purposes or not depends on whether they have signed privacy regulations with you. That is again one important question in deployment. The fifth point is, does it meet users' expectation? Remember that this entire data science exercise has only now released a final product which a user is using. So it's very important to have a user study. Ask users whether they like something, ask users whether it actually improves their experience or their performance on a particular task, etc. At this point, this user study must be done and insights gathered to take back to the drawing board. So that is the fifth step, which is deployment. Now, not just this, as we discussed before, we need to run this iteratively. So let me just make a few comments about this iteration. The first one is this notion of MVP, which stands for minimum viable product. This is a common term that you would see people in the startup world talk about. What does it mean? It means that instead of trying to build a very complex thing, you try to build simple things and then iterate. At each stage, the simple thing that you have built is actually a complete product. Let's take an example. Let's say you're trying to build a car. So one way of doing it is to go and build the tire of the car and try to make the best tire that is possible. This is one approach. The other approach is to say, I'm trying to actually build something that takes a person from point A to point B. And so let me start with building a bicycle and then go on to a motorcycle and finally onto a car. This second approach is the approach of building MVPs, whereas the first one takes one particular component and perfects that. That is not following the MVP approach. It is often found that data science is an iterative process and we need to follow the MVP method where at least a simple solution is deployed. Go take a simple data set, take a simple model assumption and actually build a system instead of making things very complex at the very beginning. That is the first comment about this iteration. The second comment is about revising expectation of success and value of data science. You'd find that there is a lot of miscommunication about what data science can and cannot do, and these cycles must be used to level set so that the entire company has a clear understanding of what can data science actually deliver. This is a very important outcome of doing this iteratively. The third step is to understand how to upgrade existing human and hardware resources. This entire process, as has been seen, involves multiple skill sets. It's important to go and ask the question, are we missing some people with other skill sets? Or should we reskill, upskill our individuals on new ideas? Similarly, on the hardware side, should we buy more GPUs and put them in-house? Should we invest in more cloud resources? All these questions need to be asked. Okay, to conclude, we have seen the CRISP DM model, which involves these 6 steps. We have gone into each step and zoomed in and seen what are the sub-steps to be taken in that. It's important to realize that identifying such a process and following that is much better than doing all of this in an ad hoc way. This also provides a compass for everybody in the organization to understand where one is, where a particular project is, and what are the next steps beyond that. Alright, in the next video, we look at the other component of engineering, which is the programming side. What programming language we use, why do we use that, and so on and so forth.